Alright, solving quadratic equations. So when we're solving quadratics, we're solving for x. And here is my first example here. So step 1 is to equate this expression here to 0. So we're going to move this 6x over to this left-hand side here. And to do that, we just take 6x from both sides. So we get 3x squared minus 6x is equal to 0. So once I've equated it to 0, I want to factorize this side. And remembering all our different techniques for factorizing, first thing you do is always to look for a common factor. And I can see here that my common factor will be 3x. So if I've got 3x here, it leaves me with x minus 2 is still all equal to 0. So now that's factorized. I've got one factor being the 3x, and my second factor being the x minus 2. Now I can apply the null factor law, which means that either this term here has to equal to 0, or this term here has to equal 0 for this equation to be true. Okay, because if we times anything by 0, it equals 0. So that's saying that being true, 3x must equal 0, or x minus 2 has to equal to 0. Okay, now we're going to rearrange these equations to find x, and to do this we would divide this term here by 3, divide by 3, dividing 0 by anything still just equals 0, so x equals 0, or rearranging this one, we're just going to add 2 to both sides, x is equal to 2. Okay, so that's our first example solved for x. So do another example here. So we've got 4x squared minus 25 is equal to 0. Now, we've got to solve this expression here for x, and its first step is already done for us. It's already equated to 0, so I don't have to do any rearranging. My second step is to factorize. Now, is there a common factor? No, there's no common factor here. Can we use any of the special rules? And hopefully you've remembered the rules. We didn't do them too long ago, but this is actually the difference of two squares, so we can use the difference of two squares rule, because 4x squared is the perfect square, and so is 25, and it's the difference of, which means it's one's taken away from the other. So here I'm going to use dots, and dots just says that if we've got one perfect square, what was it? It was a squared minus b squared is equal to a minus b, a plus b. Okay. So we get 2x minus 5, 2x plus 5 is still all equal to 0. So we've got our two possible terms here, and for this equation to be true, either this has to equal 0 or this has to equal 0, which is the null factor law. So we've got 2x minus 5 is equal to 0, or 2x plus 5 is equal to 0. So we need to rearrange these to find x. So first, for this one here, we can add 5 to both sides, so we get 2x is equal to 5. Next step would be to divide by 2 to cancel out the 2, so x is equal to 5 over 2. On this side we do the same thing, but obviously opposite here, because we've got plus 5, so we have to take 5 from both sides, so we get 2x is equal to negative 5. Again, divide by 2 to cancel out the 2, and x is equal to negative 5 on 2. So there's our two possible values for x, and we can rewrite that as x is equal to plus or minus 5 on 2. And we're done. So the trick to solving quadratics is to first make sure our equation is equated to 0. So whatever our expression is equal to 0. Then we have to factorize using whatever trick, or not tricks, but any methods that we've done previously. For now, we're not using the complete the square, that's next. But so either take out a common factor, use the difference of two squares rule, perfect square rule, or just split the middle term. And then once you've factorized each term here, you equate to 0 on its own to find possible values for x, and then just state them at the end. So I'm not going to do any more examples because we've went over and over and over expanding and factorizing, which is our previous topic. So if you want to double check, the textbook has examples of every possible factorization method that we used, but hopefully you can remember those. Look, like any questions, just remember to email me.